So what we need to be able to do to be successful for tonight's homework is we're going to have to be able to do things in section 5.6, specifically, or I'm sorry, 5.7, my fault. 5.7, comparisons. We need to start evaluating two different sources of information and comparing the numbers. Okay? So let's take, for example, some sort of X to Y ratio. How many of you guys watched the Super Bowl yesterday? 1, 2, 3, 4, 5, 6. Okay, awesome. So 6 of 20 people watched the Super Bowl. The superb owl. All right. So, a question when we're looking at something like this, if we had 6 of 20, a very simple question that I would ask you is, what percentage of people watched the Super Bowl? Okay? I will ask you, what percentage of people watch the Super Bowl? How would I calculate this? How do I figure out how do I turn this information into a percentage, David? You divide 6 by 20, exactly. So to find percentage, we take our part and we divide it by the whole. Okay? In this case, our part that we're interested in is 6, and we're dividing it by the whole, which is 20 people, right? So I will do 6 divided by 20. And that gives me 0.3. And then how do I represent 0.3 as percentage?
It would be 30%.
30%. It absolutely is 30%, but how do we know that it's 30%? Move the decimal. That's the easiest way, right? We move it over 2 spots. We put in a 0. So we call it 30%. So 30% of the people in this room watched the Super Bowl yesterday. Okay? So similarly, I might ask, what percentage of people did not watch the Super Bowl? Okay? Now we have multiple ways to find this. We could do the way that we just did, right? We take the part over the whole. We end up with 14 over 20. How did I get 14? Yeah, I subtracted 6 from 20, and that would give me 0.7 or 70%. Or if I were feeling incredibly lazy, or some might say efficient, I would just take 100%, subtract 30% to get 70%. Okay? Easy enough? That one's pretty basic. Any questions on this? You've probably all seen this before. Okay, I'm going to move on to something a little bit more complicated. So in this room right now, there's a ratio of students. And this is one way we can think about this. So the ratio of students whose last name begins with B is 1 to 4. Okay? It's 1 to 4. What do I mean when I say it is 1 to 4?
If you take a group of 4 students, there's going to be 1 student with the last name of such as B.
Yeah. And viewing it as a whole, now it's not always true. Like I could randomly pick 4 students and none of them will have the name B. I could randomly pick 4 students and all 4 of them could have the name B. But as a group, 1 in 4 of us has the last name that starts with B. Okay? So a question I might ask from this is to represent this as a fraction. You guys know how much I love fractions. What fraction of students have a name that a last name that starts with B? Okay? How do I represent this as a fraction, Connor?
It'd be 1/4.
Absolutely. 1 over 4. Again, the part over the whole. How about not with B? What would the fraction be for not with B? 3 over 4. Right? And we all see that 1/4 plus 3/4 will equal 4/4, which is the whole, so everybody's accounted for. Because everybody counts. Do you think I made this statistic up? Raise your hand if your last name starts with B. 1, 2, 3. There are 5 of us in this classroom of 20. I thought it was an interesting statistic. Because 5 out of 20 is a fourth. Okay, you guys ready? Do we need to talk about this anymore? Kind of get it? We understand how fractions and ratios work. It's pretty simple, right? But I want to make sure that we understand it, that we've done this little refresher. Okay. Next, back. Another interesting statistic, and this one is true as well. Of all CMC students, second? Yeah. Of all CMC students, %33 attended competition day.
What was competition day?
Well, you apparently are part of the 67%. Okay? So here is the question. There's multiple questions just from this one piece of data. One, okay, let's do the fraction again. How do I represent this as a fraction? What fraction attended?
Wow.
Hold on. What was it? Yeah, you'd say 33 over 100. That's definitely one way to do it. Absolutely. 33 over 100. Now my 33 is rounded, right? 33 bar is also known as a third. 1 over 3. These are roughly equivalent, so I'm going to put that little squiggle line. That's to show that it's about equivalent. Right? But when I do 1 divided by 3, I get 0.3333 forever and ever. So we call that just a third. Okay? How many times more students did not attend than did? Okay? How many times more students did not attend than did? Gracie? Yeah, so if I were to take the number of students that did attend and multiply it by some number, that would equal the number that did not attend. Okay? So think about this. How many times more students did not attend than did? So I got 33 that did, and if I were to multiply that by some number, I'll call it x, okay, that would equal the number that did not. And how many did not? We'd say 67. So 33 times what would be 67? Or if we were to view it as fractions, which is a little bit easier to understand, 1/3 times some number equals 2/3. Okay? So how many times more did not attend? 2. It'd be 2 times more. For every student that did attend, there were 2 that did not. Yeah?
How did we get the 2 times more?
How did we get the 2? So I find this fraction version to be easier to kind of understand. If I have 1/3 times x equals 2/3, what does x have to be to get it to be 2/3?
How did we get the 2/3?
Because if 33% did attend, 67% did not, and 67 is the same as 2/3. Or if 1/3 did attend, what's the remainder? 2/3. Okay? Yeah.
Wouldn't the, if you were to multiply 33 times 2, would it be 66?
Yeah, and so this is the case where our rounding really matters, right? So in this case, it would be like 2 point a little bit if we're just looking at this here. Because if I do 33 times x equals 67 and I divide by 33, I'm going to end up with 2 point something tiny, right? Let's go ahead and do it. If I do 67 divided by 33, 2.03 bar. Which as well is close enough for me to round to say that it's 2 times more. It's twice the number. Okay? So here's a question that requires some previous knowledge. How many actual students attended competition day? What do we need to know to be able to find this out? How many students go to CMC? Does anyone know how many students go to CMC? 300 students. I think we're technically at 298 right now, but we'll say 300 for the sake of the math. So how many kids were here on Thursday? 100. The actual number, of course, was 101, but we'll round. We'll round.
Wait, was that actually like 301?
100 people. How many students are in the college prep program? Which means in this building. 150 are in college prep. The other 150 are in some sort of college program. The more you know. So what percentage of students are in college prep?
50%.
Easy enough. Okay, you guys getting this? You guys grokking this? Okay, so that's going to be important for you guys for the next section for 5.7. I'm going to give you guys what have we got, 20 minutes or so? No, half hour. Good. You guys are going to have half hour to start working on your stuff. It looks like a lot of you guys are behind. Use your time to get caught up because this week's going to fly by. We have today, tomorrow, and Wednesday with new material. Thursday we're going to have the study, and that means Friday's our test. So we're already running out of time as it is. So stay on top of your stuff. And as you need help, use the people around you. Ask them for help for simple questions. If you need anything more complicated or the people around you don't know, call me over, and I'm more than happy to help.